Okay, so your notes, this is called distance speed acceleration. Okay, so distance speed acceleration time graph I will use to represent something that you are very familiar with. Now, you are very familiar with this process that you go from P6 to set 1 called DSA. You know what's DSA, right? Do you know what DSA stand for? When you go from P6 to set 1, what's DSA? No, like DSA when you go from P6 to set 1. Very good, direct school admission, right? So this is how you remember DSA. Like I want to DSA to this school. I want to DSA to that school. So this is the same thing that I want you all to remember. Why I choose DSA? DSA because there is a particular order. I cannot remember as DAS. Understand? It must be from D to S to A. Clear so far? And D stands for what? Distance. S stands for speed. And A stands for acceleration. So guys, take note. Whenever I want to convert, listen guys, very important, convert the graph. So later I'll teach you how to convert the graph. So when you want to do converting the graph, this is the order. The order means I'm going from D to S, S to A, or A to S, and S to D. So can I jump from a distance speed time graph to an acceleration time graph? No, I cannot jump. Understand? Clear so far? So I want you all to write it down. This is the fundamental. Next, another thing you need to take note, everybody look up first, later I let you all copy. Whenever it's called a distance, it's called a distance time graph, speed time graph, acceleration time graph. Do you understand so far? So today we're going to learn 3 different types of time graph and the relationship of each other. So right now, just write down all this first. Copy ready, put down your pen, we'll move on to the next part. Once you're ready, take out your pink highlighter. And then I want you all to highlight this, very important. So the 2 things that you kind of need to memorize is the basic formula and the conversion. Conversion is something that a lot of students always struggle in, but I do not want you all to struggle in it. Alright, so right now let's move on to what are the formulas and what do I mean by conversion that you need to take note of. So usually the conversion will appear in your paper 1, okay? You see this in your Sec 3 exam, you see this in your prelim next year. You might even see in O levels. It's a very typical exam question. But let's move on, okay? So right now you are a secondary school kid, so I can use a little bit of funny language. So how do you remember this? You need to remember this table as don't shit there. Okay? But if let's say your mom or dad say, hey, you cannot use this language, then you just say, oh, I meant do not sit there. Don't sit there. Understand? All right? Next, another one you need to know, but it's usually not related to this, is this one. M, because I don't want to name shame anybody that has the word am. So we can just say as a mountain. Oh wait. Oh yeah, I remember now. I used a better word because last time I used the word like I didn't like this person called M blah blah blah. I just say M blah 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 is very dumb. But now I'm very nice. I have evolved. Okay, because of all the skippity bad shit I went through. So nowadays I changed to McDonald's very delicious. Yeah, you all know what is this, right? You all learn in physics, right? So this is referring to the mass, this is referring to the volume, and this is referring to the density. So we'll go more in depth in this in the next chapter. But today we're just going to focus on do not sit there. Don't sit there. Okay? Yeah, I don't want to use the word, you know. Yeah. So what does this thingy here? So can you see this thingy here right now, guys? What does this line represent? Which symbol? Very good. Divide. Next, change color. What does this line represent? Multiply. So you all know how does this table works, right? If you want to find distance, distance is what, guys? Speed times time. You want to find speed, that means that it is distance divided by time. And you want to find time, that means that it is distance over speed. Now, I want to make a disclaimer. A lot of students make this mistake. But before I move on, I'll let you guys copy first. Once you copy, put down your pen. Very important. Because you need to know who is the mama, the king. Okay, once you're ready, take out your orange pen or orange highlighter. Ready? Once you're ready, put down your pen. So I know that, okay, I can start teaching the very important part. Can? Okay. Now, you need to be very, very, very sensitive with speed. Speed is your mama, is your king. So why do I say speed is your king? Because speed will determine the unit. For example, let's say I have km per hour, like that. What is it trying to tell me? It means that it's trying to tell me that they say that what? That they want the speed determine the unit. So if they tell you km per hour, what does that mean? Very good. What about the distance? They're indirectly telling you that the distance must be in. Huh? What? Someone said that? Yes, km. And the time must be in hours. Very good. Understand? So let's say I have m per second. So what does that mean? They say m/s. Distance must be in meters and time must be in seconds. Understand so far? Clear? Now write all this down. I think you need to write smaller because I still have 2 more formulas to teach. I kind of write too big. All right, guys. So the next one you need to remember is super important. Okay, so since now we are at this, right? You all need to understand the conversion because a lot of students here are very bad with your conversion. All right, so conversion means what? You want to go from km to meters. What does that mean? How do you go from km to meters? Uh-oh, nobody knows. What happens when you go from km to meter? What do you have to do to go from km to meters? Yes, Alyssa is correct. So Alyssa, what do you say? Yes, times 1000. How do you go from meters to km? No, it's the reverse. Km to meters. Meters to km is the reverse from km to meters. So how do you go from hours to minutes? Yes, how do you go from minutes to seconds? Minutes to seconds. Times 60. So therefore, if I want to go from hours to seconds, how do I go from hours to seconds? Very good. So it will be times 3600. Understand? So let's say this is the reverse. From here, I want to do the reverse. Let's say I want to go from minutes to hours. How do I do the minutes to hours? Divide by 60 is the reverse. Do you all understand now? How do I go from seconds to minutes? And then how do I go from seconds to hours? So now copy all this. This is what you need to memorize by heart. You need to know inside out by now already. Because this is what you learn in primary 5. So your teacher won't teach you this anymore because they expect you to know all this conversion. Now, once you are done, let's go back to basic formula again. So this one, guys, the left side copy everything already, right? So I'm going to make it really small. All right, move on. So number 2, the next one is average speed. Now, average speed, a lot of students make a mistake. They see the word average, they thought that I take the speed in the first journey plus the speed in the second journey and I average it out. Understand? It's wrong. Because average speed means I need to take the total distance and divide by the total time. It's not literally taking the average of the speed. Do you understand the English? Average speed is not the same as taking the average of the speed. What is average of the speed? Average of the speed, no, when you say everything, it's talking about, when you say average of speed, it's referring to the speed in the first part of the journey being 20 km per hour. Then the speed in the second part of the journey is being 50 km per hour. So the average of the speed means I take 20 plus 50 divided by 2. But if you do that for this way, called average speed, is wrong. Because you cannot literally take the average of these two speeds. You must find the total distance traveled divided by the total time. Do you understand now the difference? Okay, so please do not make this mistake. A lot of students always make this mistake. Now, the last one you need to take note is called acceleration formula. So, physics student, what is the formula for acceleration? Final minus, what do you mean final? Yes, so it means that it's the change of velocity over the change of time. You all know this symbol called change, right? Do you know this triangle called change? Do not know, then please write. It's called change of velocity. So it means that, what does that mean? It means that it's the difference in the speed divided by the difference in time. It's called the acceleration. Difference of the speed divided by the difference of time or difference in time. All right. So right now, let's go to conversion. Usually, what's the question that they'll always ask? They say, convert 90 meter per second to km per hour. So this is a very typical exam question. So let's take a green highlighter and green pen. Or blue highlighter, blue highlighter. Ready? Now, when they say this, guys, I want you all to take note. What is this represent? What does this mean? What does this symbol mean? Per means what in English? Per means what in English? Yes, per means 1. So how do we literally write this down? So what do I write on the left-hand side? What do I write on the left-hand side and what do I write on the right-hand side? What? 90 watts. You cannot just write 90 watts. So you write 90 meter, yes. And what do you write on the right-hand side? Yes, 1 second. Got it? Go, copy. Remember to circle that. A symbol slash means per. Per means 1. So that's the first step. Means literally, what you see in the question, you change it to math. You understand so far? So right now, can you see the word? They say the word two. Highlight. Can you see the word two? Highlight in pink. So they want you to convert. So this is a clue to tell you that right now, you need to convert what? Convert the what? Convert the what? When you say 90 meters, convert 90 meters to what? So you need to convert the units. Understand? So there's no math that is happening. I'm just converting the units. So converting means the meter will now become what, people? km. Can you see that? And the second will now become hour. So this is what the pink set means. Means the meter convert to km. The seconds convert to hours. All right? So let's convert. So how do you convert from meters to km? So guys, that's right. 90 over 1000. That's it. Very simple. That's all. Not that complicated. So right now, how do we go from seconds to hours? So what do I write? Yes, 1 over 3600. That's it. So right now, I want to change highlighter color and change pen. Let's go to your purple highlighter and purple pen. So this is in purple. Purple highlighter. Means ultimately, at the end of the day, did they tell you how many km? Yes or no? Did they tell you how many km, people? Yes or no? How many km did they tell you? Did they write 90 km per hour? Did they write 90 here? So did they tell you how many km? Yes or no? They don't tell you. So it means that this is what you want to find. Understand? Arrow. Did they tell you how many hours? Did they tell you how many hours? Very good. What did I say? Repeat again. How do you know it's 1 hour here? Per hour. Very good. You learn fast. So you see the slash hour, it means per hour. This means per, write that down. Per hour. Per hour means 1 hour. Guys, remember, write all these are very important. Per hour means 1 hour. So I write 1 here. Can you see that? So from here, what can you do? Right, take your black pen right now. We can apply this technique called the secret 7. We can apply this technique called the secret 7. Ready? Ready? Put out your pen because I'm going to show you what's the secret 7. So can you see that this is what you want to find, this blank space here, right? So secret 7 means this way. Can you see the flow? And then, which one looks Indian to you? Which one looks Indian to you? Divide or times? Exactly. Divide, right? So divide looks Indian to you. Always remember Indian compass. So Indian, always give priority to the Indians. Indians compass. Divide followed by times. Understand? So right now, how do we go about it? How do we find a box? Means if you want to find out this answer right here, that means that I will take 90 over 1000 divided by 1 over 3600 multiplied by 1. That will give me the answer. Understand? And what's the answer? 324. Good. So therefore, I know that. Therefore, the answer will be 324. What? I'm going to start at 324. Yes, km per hour. The end. And with that, congratulations. You score a 2 marks there. But sometimes teacher will put it as 3 marks depending. So it can range between 2 to 3 marks. But usually 3 marks is a little bit too generous. Usually about 2 marks max. But some school teacher only give 1 mark to this question. All right? All right, that's it. So not that difficult if you really understand the concept. It looks like a lot of steps, but if you really understand, it's not that difficult. Okay, give you guys some time to copy. Then we'll do some coloring. So take your red pen. The next part is very important. I'm going to teach you how to do drawing of graphs. Okay, now there are a few terminologies that I want you all to learn. So drawing of the graph, please take note that all these here, okay, all these here that you see. So I'm going to put a bracket. You see that? The bracket? Take note that the steepness. What do you think the steepness of the slope always represent? Very good. I hear the keyword someone mentioned. Gradient. Excellent. So sigma. Okay, so right now, steepness of the slope means it's the gradient, okay? It's representing by the gradient. So over here, guys, we will be talking about gradient, all this thingy here. Later, we'll fill in a box. I'm going to teach you all what are the different gradient. So far, so good? So let's do a little bit of recap in linear. I think there are some new students here that doesn't know Mr. Gradient. Hey, actually, you all know because it's your CG, right? You all know Mr. Gradient and draw his face before? How many types of lines do we always have? 4. So Mr. Gradient has 4 strands of hair to remind me that there are 4 kinds of lines, right? What's the first kind of line? Huh? What kind of diagonal? Downslope diagonal means it's here. Means it's what kind of gradient? Negative. What else? Upslope gradient or diagonal is positive. What else? Vertical line, not vertically down. A vertical line. Vertical line has what kind of gradient? Vertical line has what kind of gradient? Nope. Yes, undefined gradient. And last one. What do we have? Horizontal line. Horizontal line is what kind of gradient? 0 gradient. So far, so good? So I'm going to do for you guys a straight line first, okay? So everybody, let's go. The first one, the one in pink. So let's go to here first. This pink one. This pink one is what kind of gradient, people? Means what kind of gradient? Positive gradient. So I'll call this as constant gradient. And this constant gradient, I know is a positive. Understand so far? Easy, right? This one? Oh, I'm supposed to write this in red. Uh-oh. You're right already. It's supposed to be in red. Yeah. Because red is representing all the gradient. Constant gradient, positive. All right, now the next one is in purple. Because pink and purple always go well very beautifully together. So the purple one, what do you think this is? What should I write? Anybody get a clue already? Get what I write before. So what should I write? Yeah, so this is also a constant gradient. Constant gradient and what I put? What kind of constant gradient? Negative. Now, the next one is in green. So take out your green highlighter. Do not have, please borrow from your friends. You need at least 5 different colors. If next time you don't have, please remember you need to buy. Okay, the last one, this one in green. So green, what kind of gradient is this? It's not, just called 0 gradient. There's nothing constant about it. It's just 0 gradient. So far, so good? Now, let's go to the blue one. Okay, the blue one right now. So I'm going to do blue. This is so not blue. Now, the blue one, I need your attention. Look very carefully. So guys, look here. Usually from the graph, we read from the left to right or right to left. Left to right. So let's say I have this point here. Then I draw. Remember tangent, this line. Do you remember this called a tangent? Versus a point here. And this line is called a tangent. Can you see that? So can you see the slope went from here to here, right? Do you realize that is it getting steeper or less steep? Less steep. So less steep means the gradient, is it increasing or decreasing? Yes. So it becomes, G becomes less steep. That means that it's what kind of gradient, people? Yes, decreasing gradient. Understand? Next one, brown. Oh, you don't have brown, you can take another color. So do you remember we learned in quadratic, whenever we want to do gradient, it's always linked to tangent. Do you understand now the whole relationship? So tangent means right now, if you look at the one in brown, the G, the gradient becomes what? Becomes steeper, becomes more steep. So if the gradient becomes more steep, that means that in red pen, what do we write? What kind of gradient is that? Yes, increasing gradient. Okay, write all this down. Super, super important. Once you understand all this concept, we'll move on to the next part that is called the conclusion. Okay, so right now I'm going to teach you guys how to do conversion. Please listen up very carefully. Do not blink. Do not yawn. Do not basically just stay focused. Okay. So remember just now I told you there is going from D to S to A, correct? So you know sometimes the question say that, hey, I want you to convert from a distance speed time to a speed time graph. Understand? So what does that mean? It means that, can you see here how to use this? I'm teaching you how to use these notes. Listen very carefully. So over here, I am converting from distance to speed. So distance to speed means if let's say the question say the distance is this shape. If I convert to speed means this is the answer. You understand? So let's say the distance that they give you is this shape. So if I want to convert means what's the answer? This one right here. Do you understand how to use now? Okay, listen carefully. If let's say the next one, remember just now it was D to S to A. So the next one is speed to acceleration. You see that? Speed to acceleration. So speed to acceleration, that means that if the speed graph is like that, if I want to convert to acceleration, that means the answer is this one here. Do you understand so far? So that is what it meant. So if I want to go from distance to speed, that means that I look from top to bottom. Top to bottom. If I want to go from speed to acceleration, I also look from top to bottom, top to bottom. So far, so good? However, if I want to go the reverse direction, so I'm going to write DSA here. DSA. If I'm going to speed, distance, speed is going from top to bottom. If I want to go from A to S. Oopsie, where's that? If I want to go to A to S means acceleration to speed. So can you see acceleration to speed means I'm going from bottom to top. Understand? So if the acceleration graph means, do I look at the top? No, I look at the bottom. Means I'll see, okay, acceleration they give me means this one. Let's say they give me this one. So what's the answer? The answer is here. So if they tell me the acceleration is this one here. So what's the answer? The answer is here. Do you understand how to use now? And let's say it's the same thing also. If I want to go from speed to distance, means I'm going from bottom to top. Now copy all this down first. Then I'll teach you guys how to memorize these 5 graphs. So these 5 graphs you need to memorize, okay? Actually, you don't really need to memorize. If you understand the concept, it should be quite easy. Yeah. Oh, if you announce that means must be quite good. Okay, so right now, guys, remember just now I teach you all the concept of gradient, correct? Right or not? So can you see that this one you understand is decreasing gradient, right? So therefore, can you see that if it's decreasing gradient, that means that the gradient will now be going down, decreasing gradient. Understand? Does that make sense to you? Same thing for the other one. Can you see this is increasing gradient? That means that the gradient is going up. So far, so good? Then now, guys, here, this one very important. Constant gradient. Can you see these are all constant? Constant gradient means that the gradient move. If I tell you I'm staying constant, like my math score is always constantly A1. Means did I move? No. So can you see that all these are all horizontal line? But, be very careful. Can you see what is this person here? This person is the who? X-axis. So above the x-axis means what? So write down above x-axis. So above x-axis means it's positive. So does it make sense right now that here, even though it's horizontal line, but because it's above the x-axis means it's positive? Do you understand so far? Then now take your red pen and write that down. This is also the what? What's all this? These are all the what? X-axis. So take your red pen, draw the arrowhead, make it thicker and write that down. X, X, X means you know that these are the x-axis. So if I know that this is above the x-axis, means I know that this is below the x-axis, correct? Can you give you some time to copy first? Very important. Now the last one. Can you see this one, guys? It is what? Is it above? Is it below? It's actually what? It is one word only. What x-axis? Is, yes, that's on the x-axis. So this is above. The one in pink is above. So above means positive. The one in purple is below. So below means negative right here. And the last one, make sure you take your green highlighter and show it that it's literally on the x-axis. And that is zero gradient. On the x-axis means it's zero. Do you understand now? If you understand this concept, you don't really have to memorize. Okay? Got it? The next page is which one? Is this the next page? Or is this the next page? Which is the next page? This or this? Distance. Oh, distance time. Thank you. All right. So right now, let's analyze some graphs together. I'm going to teach you all the last two notes and then we are done for today. Then next week, we're going to apply all this into exam questions. So remind me to give you all the exam question notes. Then next week, also remember to bring scissors and glue. Scissors and glue. Next week, bring scissors and glue. Yeah, cut and paste. Or unless I change the notes for you all into 4 pages. Do you all want the notes to be 4 pages long? Or do you all rather me all print out in 1 page, you all cut and paste? Which one do you all prefer? 4 pages long? Or 1 page? Okay, then I'll change the note to 4 pages. Later I'll do it. Okay, guys, can I move on? Okay, I'll clear screen. You all copy exactly everything, Very important. Everything. Can you all please check whether I copy correctly? Go and check now. I'll give you all some time. Make sure you color code the same thing. Follow the same color coding. Make sure that you write everything like steepness of the slope. Make sure you write above, below. Make sure you label the x-axis. Make sure you write all the English words that is there. Everything must be there. So far, so good? Okay, clear screen. Okay. So here, let's analyze some graph together. So let me do a recap. Remember just now, I wrote that down, that the 5 graphs. So I'll do the 5 graphs. Hold on, let me do the 5 graphs. The 5 graphs. So can you see that the first graph, it is what? Is it a curve or a line? So the first graph is a curve, right? So curve up, I know that if I want to change, be it up to down or down to up? It is which way? Down. The next, after the upslope curve, I have a down, not downslope curve, it's also going up, but it's the reverse direction. And then it is up. So it can go which two ways. Then the last one, this is up. When it's up, means it's a horizontal line, but it's above. And then the next one is down. Down is also a horizontal line, but it is below. So below means here. The next one is just above that. And this one here is on. So far, so good? Understand all this conversion already? Okay. So with that, we'll be able to do. So always take note, guys. Please go and highlight this. Very important. That when it's a distance time graph, the gradient of the slope represents the speed. The gradient of the slope represents the speed. Okay, so right now, let's do. The first one. Can you see? I highlight this. This is called the starting point. So here is the ending point, okay? So the first one, it is I am. Now this purple one represents a lot of things. This purple one means I am moving away from the origin. O means origin, okay? And origin at a what kind of speed, people? At a what type of speed? Increasing speed, wrong already. Because this is distance. Distance is going up. Doesn't mean speed is going up. No. Right? So wrong. If you say increasing speed, wrong. Because guys, look here. What is this? Is this speed time graph? Distance time graph means what is going up? This is what is going up. Distance is going up, not gradient going up. When distance is going up, means the speed is what? Constant, yes. And this is how a lot of students get it wrong. Doesn't mean up means speed is up. No, this is constant speed. So what does that mean? Can you see my speed here? It is constant. So what graph is this? Can you see that this is going, my graph, am I going from top to bottom or bottom to top? So this is, you understand the lingo now, we are going from top to bottom, right? Correct enough, people? So top to bottom, this person here, guys, look here, very important. You who? Can you see this one? It's actually this person. Therefore, when I convert, it becomes just one horizontal line above. So that's why my answer is here. So far, so good? Understand? Yeah. Next. Let you copy first before we analyze the next part. So this is the next zone because there's a change already, right? Happening. So this is the one in blue. So the one in blue means which one is it? We are going from top to bottom or bottom to top? Top to bottom or bottom to top? Guys, we are going from top to bottom or bottom to top? So we all agree that it's top to bottom, right? So the top one, which one is it? Number 1, 2, 3, 4, 5. Which one? Number 5. So can you see here? And this person, if you want to convert, means the answer will be also horizontal, but it's on the x-axis. So can you see? That's why it's on the x-axis. Can you see that now? So now what does that mean? It means that over here, do you think your distance is moving? Is your distance moving? So the distance is the same. So what does it mean if your distance is the same? Like you guys right now, your distance is the same. You all never move. Means you are at rest. You're not moving. If you're not moving, means you're at rest, right? So at rest means you're not moving. So if you're not moving, means your gradient is what? 0. So does it make sense? Gradient represents speed. So that's why speed is 0. Do you all understand now? Lastly, green. So this one is the down, right? So which one? First graph, this one. Is it right or wrong, people? Wrong already. This and this don't look like the same. No. So Chauncey, you're looking at the wrong direction. You need to look very, very clear. You need to know where you're going from top to bottom or bottom to top. We already agree that this is distance time to speed time. Distance time to speed time. What did I say already just now in the notes? If distance time to speed time means, are we going from top to bottom or bottom to top? Yeah, so you must know how to look at the right direction. So right now, it means that here, this one is which one? Number 1, 2, 3, 4. This is number 4. Can you see that? Number 4. So number 4, if we want to convert, that means that what it is a flat line, right? That is below. That's why, can you see here, it's below right now? Do you understand right now? So how do we analyze this? This means that what? Huh? Can we say distance going down? Is there such thing called distance going down if you think about it logically? Can my distance like decrease? No. So, can you see here? It's called moving away from O. So what do you think the green one is? Yes, moving back to O or moving towards O. O means origin, moving towards the origin, the starting point at what kind of speed? At a constant speed. And that's how you analyze. Understand now? So, can you see just now we are all doing straight lines? Can you see my distance are all straight lines? So straight line usually is constant speed. So right now, the next one we are going to do is curved lines. Means my distance right now is curved line. Curved line means the speed is varying. So if speed is varying, I will no longer have this kind of flat line. My speed will be increasing and decreasing. Clear so far? So that is the difference between straight line and curved line. So let's go through the distance. Let's do the purple one again, the first region. So can you see the purple one right here? This one is which one? Number 1, 2, 3, 4. Yes, number 2. Can you see that? Number 2. So number 2, if I want to convert a distance time graph, can you see distance time graph, to a speed time graph, means my answer will be, can you see number 2 means you'll give me this upslope. Therefore, can you see if I want to draw, my answer is upslope. Next, this one right here. Curve, right? This one is which one? Number 1, 2, 3, 4. Number 1. You see that? Number 1. So number 1, that means that my answer will be upslope or downslope. Downslope. Therefore, can you see here? When I convert, it is continuation from here, it goes down. So that is how you draw. So now take out your purple pen and blue pen. So over here, can you see my distance is what? My distance is what, guys? Increasing. And my speed is? My speed is? My speed is what? Very good. Increasing. Because speed represents the what? How to find speed from a distance time graph? How do you find speed from a distance time graph? Guys, the answer is on the screen. How do you find speed from a distance time graph? Guys, how do you find speed from a distance time graph? Huh? No. Look at the screen. The answer is on the screen. How do you find speed from distance time graph? Physics student, you all should know, especially Chauncey. Oh, we are on speed time graph. Chauncey, you're getting all the time graph mixed up. The answer is literally on the screen. How do you find speed from a distance time graph? Gradient of who? Very good, Brayden. Gradient of the distance time graph gives you the speed. So if you look at this gradient of this slope right here, what do you notice the speed is? The gradient of this slope is what? Increasing. So that means that I know the speed is increasing. So guys, I'm going to repeat again. How do you tell speed from a distance time graph? Speed from a distance time graph is the gradient of the slope. Please memorize that. It's super important. So I know that by looking at the gradient of this slope here, I know that the speed is increasing because the gradient is increasing and the gradient represents who? Speed. So next, this one, what can we say about the distance? Decreasing, are you sure? We're going from here to here, you know. You see, I'm going from here to here. Are you sure it's decreasing? Yes, the distance is increasing. And what about the speed right here? Why decreasing? But my distance is increasing. Yes, the gradient, not the slope, the gradient. The gradient of this curve is what? How you know it's decreasing? Because is it more steep or less steep? Less steep. So less steep means it's decreasing. Do you understand? Super, super important. You need to understand this because this whole chapter is all about this. So next up, we're going to move on to a different kind of time graph. So in this time graph, we are converting from what kind of time graph to what kind of time graph? On this page. We are converting from distance time graph to, yes, write it down. We are converting from distance time graph to speed time graph. Okay, how you know? Look here, guys. Look on the screen. Distance time graph to speed time graph. Distance time graph to speed time graph. So over here, you know that we are converting from distance time graph to speed time graph. Can I clear screen? Okay. Because I want this graph. So you want all this, I want this, I want this, I want this, this. So then redraw. All right, so the next one. We should put here. I'm sure where y'all can see. No, cannot really see. What if I put this? If I put this over, will it be better? No. Make it transparent. Okay, I think it is slightly better. Okay. Now, guys. So we are going from what time graph to what time graph? From here. So everybody write it down. For this case, we are going from speed time to distance time. Now be very, very, very careful. So just now, when we say that we go from distance time to speed time, the gradient represents what, guys, just now? When we go from speed time to distance time to speed time, the gradient represents the speed. Now, when I'm going from speed time, speed time to distance time, the gradient now represents the who? The gradient now represents the who, people? Acceleration. So you need to understand the difference between acceleration and deceleration. Deceleration is a negative word. So for example, if I tell you my acceleration is equal to -20, so what is the deceleration? If my acceleration is -20, so my deceleration is 20. Very good. Because why? I told you just now that deceleration is a negative word. Now, one more thing you need to know is the area under the graph represents the distance traveled. What does that mean? Now, look here. Very important, guys. Look here. Look on the screen. Because I need to erase after that. Can you see that this is the graph from here to here? So I need to draw a dotted line. That means that the area that is here in the green part that I just shaded is representing the distance. Understand or not? Area under the speed time graph. So far, so good? Yeah, you understand this whole thing, Now I like your color code and comma. Ready? So right now, this is a speed time graph. We are converting speed time graph to a distance time graph. Now, before we do anything, we need to understand how many zones do you see? Over here, how many zones do you see? 3. So what I always like to do is I like to put my dotted line to separate out the zones. So this is 1, 2, 3 zones. So over here, I also follow. Can you see the dotted line? Here also dotted line. And here also dotted line. Understand? 3 zones. So can you see here is 5? Here's also 5. Can you see here is 12? Here's also 12. Can you see here is 15? Here's also 15. So if you cannot see, please make sure you blanco in the notes and write properly, okay? If it's too small for you guys. I repeat again. You need to do the dotted line. This is 5. Here is 5. Here is 12. Here is 12. Here is 15. Here is 15. You need to follow. So far, so good? Now, I want to do the same thing for the right side. Try not to look at the screen. Go and identify the zone yourself and then check whether you get the same answer as me. Do not look at the screen. Do it on your own. To identify the zones, then after that, check on the screen to see whether your answer is the same as me in terms of identifying the zones. No need. Just identify the zones only. Okay, right now let's start, people. So, first thing first is the shape, right? Now, before we move on to the shape, you need to be very careful. A lot of students make a mistake by identifying the shape first. No, because put a star. Ready? Guys, the key thing is don't identify the shape first. You need to find, because I'm going from what? I'm going from a speed time graph to a distance time graph. Means I need to find the who first. I find the? Guys, the answer is just 6. Nah. Gradient of the slope is a shape. We say don't identify the shape first. Find the who first. Huh? What? Yes, find the distance first. Because I'm going from speed to distance time graph. So I need to find the distance value first. Find the value of the distance. Okay, find the distance value. And how do I find the distance value? Let's go. So the first one is in pink. Can you see here? How do I find the distance of this pink graph? How do I find the distance of this pink graph? Very good. For a non-physics student, you will learn well. It's actually the area under this graph to give me my distance. Correct? So how do I find my distance? What shape do you see? What kind of shape is this? This is a trapezium. How to find area of trapezium? So area of trapezium is half A plus B times height. Correct or not? So what is my A? Wrong. What is my A? Huh? Yes, 20 plus. Very good. 50 times what's my H? 5. Very good. And the answer here is 175. And what is the units? Did they tell you for this case? Never. So for me, I don't want to care about the units, but I care about the how to solve. So the answer here is 175. So what does 175 mean? 175 means right now, my distance traveled in the first 5 minutes is 175. So can you see I input 175 right here? So far so good? Copy everything. And don't forget to copy the one in red. Very important. Once you're ready, let's move on to the next part. In orange. Okay, guys, now let's move on to the next part. The next part, how to find the area. What shape do you see? Square? No. Rectangle. Very good. How to find the area of a rectangle? Length times breadth. So what's the length? Very good. Because you get from here to here is 7. That's how you get 7. And we take 7 and multiply by 20. And you get 140. How to get 20 is right here. Now, after you copy, you listen very carefully. I don't want anyone to make this mistake. Now, guys, if you think logically, right, distance, does it mean that I was traveling here, then suddenly I become 120 like that? Or 140? The answer is 140. Suddenly become 140. Do you think it makes sense? Wherever you're traveling, you're moving. Do you think you're going more or going less? More. So a lot of students make a mistake, okay? They go and put, like, they draw a new graph. It's wrong. This 140, that means that right now, I have an add-on cumulative answer of 140. Do you all understand now? Clear? So I add on of 140. So far, so good. Now the last one, I'm going to do the one in blue. So the one in blue is here, right? So right now, I want everybody to go and tell me what is the answer for this. So go and do it on your own and check. Or rather, pass it to me once you're done to see what is the area. Which one? 36 2/3. 36 2/3. This number right here is 36 2/3. Okay, once you're done, pass it to me. I want to see whether you get the last area correct. Yeah, correct. Wrong. Next. Waiting for 3 more students. 1 student has gotten it already. Correct. Waiting for last 2 students. But this note rubber. This one no choice. This note you got to cut. This one no choice. Worksheet can, but this one the note cannot. Ask how you gonna put your file. Wrong. Your area not right. Correct. So Brayden, you go and figure out yourself. The correct answer is 85. I need to move on already. Okay, go and see how to get 85. All right, guys, let's look here, guys. 85, does it mean that I mark out 85 here? It's actually not accumulative. It's called cumulative. I add on another 85. Guys, take note, the scale matters. The scale matters. It needs to be proportionate. Clear? The scale must be proportionate. Okay? Cannot anyhow, doesn't mean that here 140, then here is like bigger or smaller. So right now, can you all tell me what is the numbers to fill in? What to fill in here and what to fill in here? So can you see my proportion is actually very good? My proportion of my scale is okay. So now I can do the shade. Understand so far? So now when I go from a speed time graph to a distance time graph, is it top to bottom or bottom to top? Yes, it's from bottom to top. Understand, guys? So right now, can you see this one? This one is which one? Number 1, 2, 3, 4. Which one is that? 1, 2, 3, 4. Which one is it? Number 1. So can you see here? Number 1, right? So the answer I will get is this one. Can you see this curve here? So that means that my answer, guys, here very important. I need to put a mark here and I'll do a curve like this. So far, so good? Okay. Next, the one in orange. The one in orange is which one? 1, 2, 3, 4, 5. Which one? Wrong. Yes, 3. Because I told you guys you need to be very careful of the x-axis. 3 means that my answer will be this, correct? So it means that right now, I'm going from here to here. Lastly, the one in blue. The one in blue is 1, 2, 3, 4, 5. Which one? Number 2. So therefore, my answer will be like this. Can you see that? So it means that from here to here, it will be like this shape. And please make sure that it's smooth. The transition must be smooth. Once you're done, pass it to me to mark. And then the next lesson, we'll continue doing this one. Okay? And doing some application. That's all for today. The end.